Hey there, Nick here. I did something cool a while ago and I wanted to share something about it and show you how you can use it to make cool stuff happen for yourself as well. So as you might know, I'm a software developer. My preferred language is C Sharp, which is a .NET language. And it's not that easy to do stuff with the Wax blockchain in .NET. Well, there is a library called EosSharp, which makes stuff a bit easier, but there's still a lot of manual work that you have to do. So if you want to interact with a smart contract, you have to know the name of the table, how it looks like, what the data types are, etc. So I thought of something to make that a lot easier, and I pitched it to Wax Labs. And Wax Labs funds projects like this that helps the community. And I wanted to show you what I made and how you can use it. And the example that I will show you is how to, if you have a non-custodial wallet, so a self-hosted wallet, how you can renew your vote for your CPU and net and claim the voter rewards for that. So then you'll make a program that you can run every day and it will just claim and renew your vote. So that's a really nice thing to do, I think, and it makes life just a lot easier. And it's also a great way to showcase how you can query data on the blockchain and execute transactions. So this is the labs proposal. The code, the source code for what we're using is all on GitHub. It uses my project called ABI2CSharp and it uses a modified version of EosSharp. I had to tweak some things to make it work with all the custom code that I generate. But I think we'll just dive in and let you show how you can use it. So you can pull this out from GitHub and just compile it and use the binary, or you can dive into the code and learn more, but that's for more advanced people. So I think we'll just try that for now. I also applied for a Pomelo grant, which I got some funding for, which is cool, to do like this video that I'm doing now with the proof of concept, but also for EOS. So if you like this one and are more interested in EOS or other Antelope chains, there might be a video about that in the future as well. Okay, so let's build our project. The first thing that we do is get our developer console. It looks like this. So I do developer and I start the Visual Studio 2022 developer console. I do this because this has a lot of the paths that we need already, so it's easy to execute stuff. So I go to the root of my drive and let's make a directory called POC for proof of concept. And in there we're going to pull in the repositories for ABI2CSharp and my modified version of EosSharp. Then we'll use NuGet to restore the dependencies that they require and use MSBuild to build them. And we'll go from there. So let's do that first. I'll move it to the side here. I'll copy this URL and I'll do git clone of this. So that's part one. Then we take this one as well and we do git clone like that. Okay, so now we need NuGet, and it's just easiest to get the latest binary from their site. So we use curl, which has been in Windows for a while, which is really cool. If you're a Unix user, you'll know curl, but it's cool that it's available on Windows as well. So. And then it's this.nuget.org/ for me it's winx86 command line latest /nuget.exe. Okay, so there we have it. We have those files. So now we need to restore the NuGet libraries. Every one of these projects has some dependencies like newtonsoft.json and stuff like that. So we just use this to restore all of that so that we can build it. So we do NuGet restore, and then we go to the project file that we need to restore. So we start with ABI2CSharp, and we restore that one. It takes a bit of time. NuGet restore. No, we do EosSharp. And then we do EosSharp, and then we do EosSharp again. And we need to make sure that we do the solution because there are multiple projects and we need to make sure that all the dependencies are restored there. So the next thing that we need to do is actually build them. So we do ms build, and we do ABI2CSharp, and we can actually do it like this. So ms build, we can rebuild that project, that is fine. And for the second one, let me see, ms build, and we want this library actually. Yes, we want this specific project, so that's one nesting deeper, and it's just EosSharp, and it has the core and everything that we need. So we need to build that, and I'll be sure to put all the commands, etc. in the description so you can easily replicate it yourself. So now that we've built both of them, we want to actually have this in the path. So we can do path is, and then you do percentage path percentage, and then we add it. So we do C document POC ABI2CSharp bin debug, and then net core API like this. Okay, so now even if we're in a different folder, we can execute the ABI2CSharp command from anywhere because it's now part of the path that we search. So now we need to make a folder for our actual project that we're going to do, and let's just also call that POC. So it's very interesting, I know. What we need to do now is .NET new console. So this builds a small sample project, and we do .NET add package new console.json. This adds the Newtonsoft.json project, which is a NuGet package, and it will add it because we will need it later. We also, since we will be doing voter claiming, we need the EOSIO contract on Wax. So we'll do ABI2CSharp EOSIO. And this is the code that I wrote. It will now, and I see a typo in it, manually. It will generate a lot of code and the EOSIO.cs file with all the logic that we will need. So for me, since I have the file association, Visual Studio is weird like that. It can I have multiple versions, and because I want to make sure that .NET or Visual Studio 2022 starts, I can do dev and then poc.cs project. So this will start Visual Studio for me, the proper version that I want, and because it's the developer tools for the 2022 version, this one will do it like that. We're not done yet, because if we will try to build this, it will have a lot of errors. Right. So it says it wants to do lots of stuff, but it can't. So first things that we need to do is we add a reference. So we can go to browse, and we go to like this, EosSharp, EosSharp, bin debug. .NET standard, and we want these two, so we add those as a reference. Okay, that should get rid of a bunch of errors. Boom. There is some other settings that you might have to change because there is a preview features, and sometimes you need to use previews of the .NET SDK. So let me open this. And sometimes when you do this, it will error out, but it doesn't. That's nice. Just know that if there's an error there, you need to do that. And let's see, .NET version, yeah, this is all good. Sometimes when you use some features, you might need to set a specific language version. So what you can do is you can, after the target framework, you can set language version 10, for instance, and that will force usage of some of those things. So yeah, basically this is already test code that we can run. So if we look at the EOSIO file, there's a lot of stuff in here, right? You can see there's contracts, EOS.io, and beneath that there's actions and requests and all sorts of namespaces. So it generated all this code for us, including some tests, and I think those are easier to run. So you can see it comes pre-configured with an API endpoint and the chain ID, which makes it easy. So what we can do now is we can get rid of that, and we can do ABI2CSharp.test.run. And this is asynchronous code, and we can also do ABI2CSharp.test.run type serialization. So if this completes, we don't have an error. So you can say serialization tests succeeded. So and we can run this. Boom, and it says here first row from ABI hash table is owner with the dat and the hash. So this is something that it queried out of the Wax blockchain. How does that work? Basically, the code is written in a way to generate a test file based on the first table that it exists. It will try to pull the first record with the default scope and then list that. So this is all generated out of the other stuff. So this isn't as impressive, so we can do remove that, and let's make something that's actually useful. To execute things with the EosSharp library, you need to execute transactions, and it's a bit, there's a lot of boilerplate code that you need to write every time you need to do a transaction. So I came up with something that makes it easier, at least I think it's easier, and that's just a simple wrapper to execute code and help you do that. So I think we'll write that now and just use that, and it's something that you can copy paste later on and use it for other stuff as well. So I should maybe make that part of the test code that I wrote just to make it easier, but yeah. So we write an asynchronous task, and we'll let this return a result message, a transaction ID, and if there was an error, right? And we call it execute. Now we need to feed this some things. First of all, EOS API. We need to make sure that it's imported correctly, so we need to use this part because that's where this namespace resides. And we'll do this in a way that we can either feed it one action or multiple actions, so that we use the params keyword for that. And basically that lets you define an array of type, and then the compiler lets you either do 1, 2, 3 or 100 of them in line. So it's easy to have multiple overloads like this. So we need to do actually action array actions, and this is also a type that we need to qualify here, because there's also system.action, which is like a generic lambda. So here are the actions. We will need to define the result that we want to return. So we do result and we do return result. Okay, that's the basic. It will complain because it's not set, right? Use of unassigned local variable. We'll fix that later. I can do this is null to get rid of the complaining error, but it does nothing. Ah well, I could do it like this, but that's just ugly. So we'll just make sure that we do it like this, and then every code path that happens after, we will make sure that it sets it. So we need a few things. We need like something to interact with the Wax blockchain. We need a serializer, and yeah, let's just write it all out. So we do var wax is new EOS. And let's use that namespace as well. And the cool thing is, this is not the... you can use everything that's in this API variable here to describe all the other things and initialize them. So that really helps. If you do this in a more structured way, you might not want to do it like this and declare it somewhere else and have to initialize this neatly. But this is just a nice and easy helper to get you started. So don't take this as the best way to do it. It's an easy way to do it. That's very understandable for now. So we need a serializer, and that becomes a new EosSharp.core.providers.api, and we feed it the API. Right. So now we need to make a new transaction. So T-Rex is new transaction. And in this we need to set some defaults. There are like budget options that you can set for a transaction, like how much data it can use or how much CPU. But we don't set those. And also like the targets you can hit are very big, so that they're not fine-grained at all. So they're a bit, they're not so usable really, but it's there in some cases. I've used them in the past, and for some scenarios they're useful. But so we just set them to 0, which means infinite, and that way it won't get in the way. We don't set a delay. Delayed execution, I think it has been revoked for now, at least for cloud wallets. I'm not sure if it's still able for self-hosted wallets, but yeah, that's a whole other topic. Context-free actions is new, and we can use the new language feature here so that we don't have to type out the entire name. They will just be blank, and basically this is a list of a type, but we can use the new operator like this because we use the latest version of .NET. And we do the same here. We create a new one so that it's defined, but there's nothing in there. Lastly, its actions is actions.toList. So this is our params here, which is an array, and this can be either 1 or more entries, and this way we shape it in the way that we need to. So now this needs to be serialized, so we do var backed T-Rex is await ABI serializer, because this can do web calls to actually retrieve things from the blockchain if it needs that data to serialize it. And we do serialize transaction like this. Now we need to get the keys, and they are also in the sign provider that's linked to the API, if you do it correctly. So we can do it like this. So we do await api.config.signProvider.get available keys. Come on to list. So these are the required keys, and now we can make the signatures. So we do var signatures is, and now we do await api.config.signProvider.sign, and we do the same chain ID. And you wonder why it has to pass all of this, because it should be able to self-inflect most of this, but yeah, it's we feed the transaction. So like this, we signed the transaction, and this hasn't broadcasted it yet. So what we now need to do is actually do that last part. So we do a try catch because exceptions can happen, and it's an API, I think API error exception. Yes, call it X. But first, let's assume it works. So we do string tx. So this will be the hash for the transaction is await wax. So create transaction here X. And then we do result is we have no message really, because the return types are not enabled, I think. But yeah, you can do stuff if you want and pass it back. But in this case, I just use it to set an error message. So this will be the transaction ID. There will be no error message because error is false. On the other hand, if it fails, we do console.writeLine, and we see an error has occurred. And depending on the type of error, sometimes you can extract part of it. So there's usually a semicolon, and you want to get the part after the semicolon. If not, you just join everything together. So let's do that now. So we do var parts is x.error details of first or default, and we do dot method dot split like this. We do if parts no parts length 0 larger than 1. Okay, so this means that it was found and it matched and it split. Then we do result is we do parts 1 dot trim null true because there is an error, else we do result is, and then we just concatenate all the messages. So the string.join environment.new line for each of them and do explicit error details. Let's select punt method. Okay. Actually, I think might be message, not method. Like this, okay. And then we do console.writeLine. So either way, the result will have the error message, so we print that out. So now we have satisfied all the cases, and the result will always be set. So this is just an error or a little helper to let us execute code. So next is the thing that we actually want to do, which is claiming our photo share. So so let's do sync task claim and check and claim word like this, right? So we need to specify our wallet. Dot name. Let's just do using ABI2CSharp model. I'm just going to do it like that. So to name wallet is, and I actually have conversions for this. If you go to definition, there are conversions from and to name, which converts them back and forth. So it's really nice that you can just set it like this, and it will convert it inside into a 64-bit integer that it can use. So yeah, that's just some creature comforts there. Let's also define the proxy. Proxy to vote for this, and I always vote for Wax community. It's 12 characters, and you are free to pick whatever you want, right? So now we need to declare the API. So do var API is new EOS API. And we do new EOS configurator. Like this. Okay, actually I need to call it like this. So we get sign provider is new blah, and that is EosSharp.core.providers.default sign provider, and we need to put in a private key here. I'll put mine in later, as you might understand. HTTP endpoint is, and then we need to actually put in the chain API, and chain ID is as well. So we can get that from the test. Oh, is it down here? Yes, so we can just take these two and just copy them here. There are multiple endpoints, this one just works, it's okay. And we need to actually specify a new key handler, I think. Right. Yes. Okay. Let me think. So we have that. Now we need to actually get the data from the chain to see if you can vote and have voted before. So that's stored in a voters table. So we do var vote info is await contracts. Actually, let me just make this easier. So I can do using EosIO is ABI2CSharp contracts. So I made an alias here, so I can just use this name now. Let me see, tables of voters dot query. I feed in the API, right? And then I set a lower bound, which is wallet. Upper bound is wallet. And I actually can leave the rest to the default, so like scope, etc. Max results, we don't care. There's only one result really that should return here, so that doesn't matter. Rows dot first or default, right? Because if you haven't voted yet, this one will be null. So if vote info is null, never voted before, else has, we will implement that later. So we will check, let's just first tell that we have not voted before. No vote info found, will vote before proxy. No, proxy to vote for. Yeah. And now we're going to execute something. So we do await execute. We feed in the API, and then we do EosIO dot requests dot vote producer dot create action. So this one is a helper that will create the action that you can execute, and it will pre-fill some stuff. So I tried to make everything as easy as possible. So we feed in the wallet because it needs that context, and then we can do new voter is wallet, and then proxy is not proxy to vote for, like this. Okay, and this will actually execute your vote and vote for the proxy, and you need to vote in order to get the rewards the next day. So it can take some time for stuff to be reflected on chain, so I usually write a helper to help me with that. So maybe let's do that now as well. Let's see. Okay. Sync task time span. Wait for change. And we do an action. No, let's do a think task bool check. Right. So we will feed it logic that we can execute. So we do stopwatch as is new. Like that. And do as we got start. So we start counting. So the bool has changed is await check. Right, and we do while not has changed. Let's also specify how long we want to wait, so we can do int check interval ns. Let's set it to a second by default. We can just do thread dot sleep like that, and then we do has changed. No, has changed has changed. Okay, is wait check. Okay, and then we do stop, and then we return sw.lapsed like this, right? So this is just a little helper that you can use. So we can do now we can track how long it took for something to update, right? So we can do var elapsed is await for change, and we do async. Okay, so we do var fresh vote info is await, and actually we can just copy that. Boom. And then we can do return fresh vote info dot unpaid voter share last updated equals vote info dot unpaid voter share last updated or daytime dot min value true, something like this, right? And then we can say console.writeLine it took elapsed for the API to reflect the updated data. Okay. So now it has voted, and we need to wait a day before we can claim it. So let me just also write that console.writeLine. We voted for the proxy. Now we need to wait 24 hours before we can claim our first wax vote reward. Let's not be too happy about that. So now we will do the actual voting and claiming, and yeah, that there's some math involved. It basically, I'll just write it out and I'll show you. So we need to get the global table for to do that info. So we do wax global is, and we do await EOSIO dot tables dot global dot query. We feed it the API, and then we get rows. So no, wait, like this. And we just assume that it exists because it needs to exist for the chain to function. So maybe the first block, it doesn't exist. After that, it's okay. So we can just assume that it exists. That's why we do rows 0. So we can write that out to the console to show. Actually, you can use JSON convert. That's what we use. Newton software. Dot serialize object wax global, and we do formatting indented. Okay, so that it's nicely formatted. So now we need to know how much time has passed. So we do var seconds elapsed date time.ptc now. Subtract vote info dot unpaid vote share last updated dot moment total seconds. Okay. var unpaid voter share vote share is, and this one will be vote info dot unpaid vote share plus unpaid vote share last change rate times seconds elapsed. And now we need to calculate the reward. To do var reward is wax global dot voters bucket times, and then we do unpaid voter share divided by wax global dot total unpaid vote share. Okay, so this is basically what you're gonna get, and now we need to know if it's actually, if enough time has passed. And I always want to write it out, so I calculate the reward even if it's not ready to claim yet. So we need to compare the seconds. Okay, let's do this. So we do const int seconds per minute is 60, const int minutes per hour is 60, const int hours per day is 24, const int second per day is seconds per minute times minutes per hour times hours per day. So now we have seconds per day. So we do if seconds elapsed smaller than, no, actually we need to know if it's larger than day has passed since claim. And now we can do console.writeLine. So we do voter claimable, and we do reward divided 1/8, and this might look like magic, but it's not. Let me quickly explain. 1e8 just means a 1 with 8 zeros. And why do we divide this? Because everything stores in integers. Wax has 8 decimal positions, so it's written out like a 1 with 8 zeros if you want 1 wax. So that's also how you divide it if you want the exact precision. And that's to prevent floating point rounding errors, etc. So we do it like this. We get the reward, we divide it by 1 with 8 zeros, and we format it with 8 decimal places. So that's the F8. That just means it's a float and we want to have 8 decimal places of precision, even if it's all zeros. So that will format it in the way that we expect it. Yeah. So I think now is the time to claim the vote, the wax. So let's do that. So we do an execute again. So we do await execute API, and now we do EOSIO dot requests dot voter claim, create action, wallet, and we do new this, and here we do owner is wallet, like that. So yeah, that's basically doing the claim. So that's also very easy. Let's do a console writeLine. Now we need to renew the vote. So we do renewing vote for proxy in this proxy to vote for. And we already have this logic here, so let's just put that in a func here. So we do func task vote for proxy is async this, and now we take this code here, and we can just do await this, and we can do the same below here. Dun, dun, dun. Okay. If I do it like this, I don't need to pass it in because it needs this data, and this is a local function. It can access that in the scope. So I should probably just make it a function that accepts this, but this is fine. So we do vote for proxy, and that is done. And I think that we can do the else is just to print out how much wax you would get if you were to wait. So it just calculates how much you got by now. So you say too early to claim, Let's see. So we need to wait vote info dot unpaid photo share last updated dot moment dot add days one dot subtract date time dot etc now. So basically that is how long we still need to wait. Then we can say we accumulated this so far though. Okay, basically that's it. So yeah, I can run this now. It will probably error out because I don't have this one set. Let me see if I can no. Otherwise, I'll cut and I'll put in the private key and run it. So let's just go here and I'll baby step it. Boom. I actually need to call this code. So in the end we do await this. Let's run this. Boom. Vote info is not null. So here, and let's just go, I'll just go here. Will it do that? So here is, by the way, the global that it spit out. Let me see if it killed. Let's see. Too early to claim voter pay. I need to wait 11 more hours. We accumulated 22.4 wax so far. So yeah, it works. Great. Yeah, I actually have a custom permission set up so that I can use a key that I don't mind losing since it's hard-coded in the program. And there's actually something that you need to do for that as well, I think, because when you create the action, I think there is a permission, right? So you can use active is the default permission, but you might need to set a custom action. So for my wallet, I have a custom voter claim, I think, permission. So if you have a non-standard permission, so it's not active, you can set that on the create action. So there's an overload that lets you change your permission. So yeah, that's it. A simple piece of code. I think you can ignore the wait for change and execute code. If you just look at what you need to do to claim your vote rewards, it's basically just this code. And that means setting up the API, which is basically just some values that you copy paste. You retrieve the vote info from chain. This is the logic to vote for a proxy, which as you can see is also quite small. And this is just all the logic that you need. So I hope you like it. If you have any questions, feel free to ask. And yeah, I hope you think this is as cool as I think it is. Bye bye.